Now let's begin with the first of the biomolecules. We discuss about the lipids, and these are examples of lipids. You're very familiar with this. You have here cooking oil, coconut, olive oil, avocado, butter, and several other oils and waxes that we are very familiar with. Now, just remember that when we talk about lipids, there are good lipids, bad fats and oils, and ugly, and this will be very helpful in maintaining our health. So if you would like to eat some good essential and healthy fats, you can take note of coconut, avocado, grass-fed butter, ghee, wild salmon, olive oil, seeds, nuts, pasture-raised organic eggs. So these are very important fats or lipids that can give us good health. But in terms of bad, these are the refined fats and oils. So this will include canola oil, grapeseed oil, corn oil, soybean oil, sunflower oil, safflower oil. So this can be used as cooking oils, but you have to make sure you only use a small amount so that this will not be bad for your health. And totally, we should try to not to eat this, to avoid this ugly fats, which are called trans fats. So you can find this in the chips, in burgers, donuts, pastries, and French fries. So these are the different kinds of lipids. So if we're going to be asking, are fats bad or good? Therefore, they are both good and also bad. Bad because it can be very bad for our health. Good because it will be very helpful or is needed in the maintenance of our health, our life, like essential fatty acids and the cell membrane. It needs lipids. It needs a certain amount of cholesterol. So both good and bad would be the function of the lipids. So another thing we have to take note of is the definition. Lipids are fatty or waxy organic compounds and readily soluble in a non-polar solvent. So this means we already are very familiar. It doesn't mix with water. So oil and water doesn't mix, and the lipids will only be mixing with non-polar substances, not with polar substances like water. So let's talk about the function. So here are some of the functions we should take note of. E, I, P, H, S, L. So let's try to remember all of this function. The letter E is energy storage. The other one, letter I, is insulation. Letter P is protection. Letter H is hormones. Letter S would be structure. And letter L would be lubricant. Perhaps we can just memorize it this way, SHIPL. So this will be easier to remember or to memorize for the examination, also for college entrance examination. So SHIPL would be the function of the lipids. S would be structural. And when we talk about structural, you have to remember that it is very important for the formation of the cell membrane. So it gives structure. It is very important because if it's not for the lipids, if not for the cell membrane, life would not have a reason, because the cell membrane allows the inside of the cell to have integrity and allow the different functions and processes that are needed for life to occur or for life to continue to happen without any disruption coming from the environment. So it separates this integral part or the internal parts of the cell from the environment. So that could be part of what we call a structural. Another one would be hormones, and the hormones are actually part of the or lipid base, particularly steroids. So you have their growth hormone and insulin. So there are several types of these hormones. Letter I is for insulation. So you're very familiar with the Eskimos. So Eskimos are actually big bodied people because of the amount of fat that they have, and because it's very cold in their place, particularly in Alaska, there will be a need for them to make sure that the heat from their body won't come out, and insulation by the fat will prevent a lot of this heat to go out, and thereby allowing the Eskimos to survive in cold weather. Letter P is for protection. So if you remember our discussion last time, our bottom has fat so that it protects our bottom when we are sitting down. So it's more comfortable to sit down rather than simply having bones when we sit down. Letter E is energy source. So it can be metabolized as a source of energy for our body to continue on surviving. And letter L would be lubricant. And if you're familiar with engine oils, this would be very important for the parts of the car, the engine to to move uh, seamlessly. So that's why it's very important to put oil or engine oil in the engines of cars. It can also, if you have a squeaky door, you just put oil as well, and it will prevent the metal parts to squeak. So this is SHIPL: structural, hormones, insulation, protection, energy source, and lubricant. So those would be some of the functions of our lipids. Now, if we talk about the different classes of lipids, this can be simple, compound, and derived. So we just gave an overview of this. For the simple lipids, these are what we call as esters of fatty acids, and there are three of these example in our SLG: FWO. What do you think would be the three simple lipids that was discussed in our SLG? The first one would be letter F, fats. Second one would be W, waxes, and the other one is O, oil. So those are examples of what we call as simple lipids, and the simple lipids are esters of fatty acids. So fats are esters of fatty acid and glycerol. As you can see in the picture here, the glycerol will be the blue portion, while the fatty acids would be the green portions over here. Waxes are actually solid lipids, and these are esters of long chain fatty acid and long chain alcohol. So just remember that. So waxes have alcohol, an alcohol portion, and fatty acid chain, while oils would be fats in liquid state. So very familiar with all of us. Now, the other classes that we talked about in our class, aside from fats, we also talked about phospholipids and also steroids. Phospholipids has this structure wherein there is a hydrophilic head and there will be hydrophobic tail. We'll discuss it in a little while. And these are esters of fatty acids with alcohol and other groups. So these are compound lipids because they have other groups. Just remember phospholipids. And then there are derived lipids because they are composed of hydrocarbon rings. So the ones that has a lot of rings like this one would be called as steroids. So again, the classes would be fats, which will contain the oil, the waxes, and the fatty acids. The phospholipids, which has two parts, the hydrophobic head and the hydrophilic head and the hydrophobic tail. And also the steroids, which will be made of rings. As you can see here, these are the different main types of lipids that we talked about in our SLG. Now, let's talk first about fats. The fat is actually made of two parts, as we have mentioned. It's made up of glycerol. This is a 3-carbon chain, and then you have a fatty acid like this one, wherein it will contain a COOH at the end. And if you would be combining them together, or in order for us to produce fat, you need to bind them together, wherein water is released. As we recall, this is a dehydration process, and then this fatty acid will now be connected through a covalent bond through to the glycerol. And this is the example, as this is what we call as a triglyceride, because there are 3 of these fatty acids, and the linkage that you have to remember is it is called an ester linkage between the glycerol and also the fatty acids over here, forming what we call as fats. Now, there are 2 classes of fats that we also need to take note of. One is called saturated and the other is unsaturated. We discussed this. And what do you think, what do you remember, which one would be contained the double bonds? It will be the unsaturated. Okay, very good. So saturated fat, wherein all of the maximum number of hydrogen atoms possible, and there are no double bonds are present. You will be seeing here that it's very straight, and the reason being that there are no double bonds here. And then an example of this saturated fat with straight fatty acids would be butter and animal-based fats. That's why it's very unhealthy to eat a lot of this saturated fat, because it will cause fat deposits in our blood vessels, thereby causing what we call as cardiovascular disease. We'll go back that a little bit later. So saturated fat would be containing straight hydrocarbons, straight fatty acids, and there will be no double bond present. And of course, unsaturated fat will have one or more double bonds, and because of the presence of the double bond, it will cause the fatty acid to bend. Unlike the saturated, which is very straight, the unsaturated will bend in several places where there will be double bonds. And this would be the unsaturated fat are liquid in low temperature compared with animal fats or unsaturated saturated fats, wherein it will be solid in low temperature. So this would be some of the comparisons between them. So these are plant-based fats which are unsaturated. This is very healthy, and we should take a lot of this. So as we mentioned, fats that are unsaturated, if you take a lot of this can cause or contribute to cardiovascular disease, where there will be plaque deposits happening in our vessels, and this can cause what we call as heart disease, stroke, and also heart attack. So we have to be very careful that this won't happen in our blood vessels. So refrain from eating fatty foods, especially those with trans fat, like burgers, processed meat, and French fries. This would be very unhealthy, and in the long run will cause what we call not only diabetes but also the cardiovascular diseases. So we're finished with the fats. Let's now go to phospholipid. This is another class of the lipids, and fats would contain two important parts. This would be the hydrophilic head and also what we call as the hydrophobic tail. So the hydrophilic head, by the name itself, it is hydro meaning water and philic meaning loving, so it is attracted to water, while the hydrophobic tail, hydro meaning water again and phobic meaning it's afraid, so this is not attracted to water, but rather it is attracted to non-polar substances like other oils. So you will be noticing here that the phospholipid bilayer, our cell, will be made up of this phospholipid. So this is amphipathic, meaning polar and also non-polar would be parts of the same molecule, and this will allow it to produce a lipid bilayer, which would be the formation of, or the structure of our cell membrane, allowing the integrity of the cell inside of cell to be maintained, because it is allowing the water outside not to go in, and the water outside and all the substances and all the process happening here to remain inside of the cell. So it's very important for life. And for my cell, this is a droplet of phospholipid, wherein outside is water and inside would be non-polar substances like oil. And this is very important for like mayonnaise and for salad dressing, because fat would be distributed or will be dissolved inside of water, producing what we call as the mayonnaise and the salad dressing. So it enables fat to be dispersed inside of water because of the formation of micelles, wherein the hydrophilic head would be attracted to the water outside, and the oils will be attracted to each other, maintaining the ability for the oil to be dispersed into the water. Finally, we have here the last class here, the steroids, and the most important thing we have to remember here is that they are consisting of fused rings, particularly more or less four fused rings. As you can see here, cholesterol, estradiol, testosterone, vitamins. So this would be hormones and cholesterol. So this will contain all of those rings. So those would